So Jeffrey Steiner, we're very privileged to have him with us today as a speaker. He's a national program leader for agronomy at the USDA, National Institute of Food and Agriculture. He has broad experience with multi-institutional interdisciplinary research teams in food production, natural resources, and bioenergy systems. He is responsible for research programs and engagement with partners and stakeholders involved with the sustainable production of commodity crops, forages, and industrial hemp. Integration of new technologies to accelerate improvements in production and design of new systems to address natural resources conservation and market challenges. Jeff spent 24 years with the USDA Agricultural Research Service as a national program leader and research scientist, and served as an agriculture associate research dean at Colorado State University. As senior energy advisor in the USDA Office of the Chief Scientist, he provided political appointees and government agency officials with technical briefings and support for writing and implementing the White House Interagency Working Group's report, Growing America's Fuel. Jeff has supported partnerships with the Department of Navy, Commercial Airline Alternative Fuels Initiative, Federal Aviation Administration, and Department of Energy, including Farm to Fly and the Navy DOE USDA $510 million Title III Defense Production Act Advanced Drop-in Biofuels Production Project. That's a mouthful.
Yeah, sorry.
He has also represented USDA internationally for the Global Bioenergy Partnership, the USDA DOE China National Energy MOU, and the Energy Climate Partnership of the Americas. Jeff received his PhD from Oregon State University and his BS and MS degrees from Cal State University, Fresno. He is a fellow of the American Society of Agronomy and Crop Science Society of America and recipient of the Career CSSA Seed Science Award. Jeff was raised on a diversified family farm in California near Visalia. I'm not quite sure exactly where that is. His parents grew cotton, alfalfa hay, grain, fruit, and nut crops, and raised hogs and cattle. So, Jeff, thanks very much for agreeing to present, and we're interested to hear what you have to say.
Good deal. And again, I just really appreciate the opportunity, and it's a really good timing, your seminar, and just the way some of the policy legalities have been worked out recently regarding industrial hemp. I'll talk a little bit about that in that talk, but again, just really good to be here. So as you see with my title, I've got a lot of background with biomass, agricultural production in general. And so when you look at something like industrial hemp, it is another option, for a biomass feedstock. And so therefore, I want to talk about industrial hemp in that context. And again, there's positives, and I would say there's also challenges. And so, not to be cynical about it, but again, I think it's one of these new crops, like any other new crop, that you have to go in with your eyes wide open, understanding what it really takes to make a crop such as this move along. Okay, now I didn't want to move forward. There we go. I just want to test something for a second. Okay, I got it working now. Okay, what I'm going to do today is I'm going to talk in general about our right size perspective on sustainable biomass feedstocks, talk a little bit about industrial capabilities and capacities, and then move into what's really important, particularly in a state like Pennsylvania that now legislatively, or legally can work on industrial hemp. Talk about what are the USDA resources that could help advance the science for industrial hemp. All of this is even happening now because of the change in the Farm Bill that allowed industrial hemp to get onto the policy landscape. It goes back to the 60s when marijuana was, cannabis was classified as a Schedule I narcotic, and that put a lot of policy issues into play at that time. but it's with the 2014 Farm Bill and defined as less than 0.3% THC, the psychoactive compound in cannabis. As long as it's below that level, then it's considered as industrial hemp. And so that has caused a lot of other policy issues, conflicts with Drug Enforcement Administration, with Food and Drug Administration. But again, as I mentioned before the seminar, in the last handful of months, a lot of this has really come together. And that in combination with policies that have been, legislation that's or initiatives that have been taken out in the states that have made industrial hemp a legal crop from an agricultural standpoint. So everything depends on this. I refer you guys to that website at NIFA, which gives the most up-to-date information. It has a good series of questions and answers that are there. Again, I'd really refer you to this website so that you can get any background information that you needed regarding industrial hemp and its status and how that works for research. Okay, so let's talk about what is a right-size perspective to biomass feedstocks. First point to make is that it's really important to think about the end as your starting place, products that you expect to be producing from a biomass feedstock. That has to then dictate what is the conversion pathway that could be used to come up with those end products. And then that then tells you, okay, based on what I want to produce, how I'm going to make it, that then pretty much lines up what the biomass feedstock would be. And this is not an all-inclusive list, but we can think about bioenergy, biofuels, other bio-based products. And then, one series of pathways through that could be through sugars. You can take cellulose, turn cellulose into sugars, and go the same route to get your bioenergy or biofuels, other bio-based products. There's also a series of conversion pathways that can take cellulose directly to these type of compounds or these products. And then, of course, there's lipids and how hydroprocessing and other forms of conversion could also take oils, fats to these products. Again, you have to think about how are you going to get to where you want to be and build backwards from that. The point to all this is when we're talking about bio-based products, we're talking about a landscape perspective that where you are has a lot of effect on that. And so therefore, you also want to think about, okay, what are those regional characteristics? The people, the places, available resources that you have. And you're going to have to build upon, what are people already doing? What are the businesses that are in place, the supply chains, the infrastructure, and the government conditions. And what I mean by government conditions is that in Pennsylvania, because of the legislative frameworks that you have to work within, you can have industrial hemp in your state. There's still states where industrial hemp is considered as cannabis, Schedule I narcotic, and so it cannot be grown there. So, just looking at these principles, putting that all together, people, places, the resources available. Okay, then when you start thinking about industrial hemp, you're going to have to say, okay, what are the production strategies and that are going to have to be developed for hemp? And it's realizing that there are certain, based on this previous slide, there's a certain set of conditions that make up your part of the country, but there's different sets of conditions in other parts of the country, and so different systems. Okay, and so therefore each region, based on what is there, what the resources, the people, the biophysical environment, everything, that's going to pretty much dictate then, what are the sideboards that you can work within that you now want to consider industrial hemp and how that fits. Okay, just kind of a rule of biophysics is that it's important to think too about the net primary production, productivity that you have in the country or where you're located in the country. And there's kind of a magic line at the 100th meridian. And, east of the 100th meridian is considered as, humid, temperate environments. Everything west of the 100th meridian is basically considered arid. To the east of the 100th meridian, a good deal of agriculture. Majority of it is rain-fed. To the west of that 100th meridian, everything has to be pretty much irrigated, although there is dry land. But this is going to have a big effect on productivity and therefore the economic competitiveness of any crop that you grow, much less even industrial hemp. And it's realizing that it's down in the southeast portion of the country that you have the greatest net primary productivity. And as you move away from there, net primary productivity decreases. You see out in the west, it's very low natural NPP, but that doesn't mean that those areas can't contribute. It's just that you're going to have to supplement that system, through irrigation, or in any of these areas you could go to indoor production. But that's going to have an effect on really how much material can you naturally produce in any part of the country. Okay, another factor to consider is that with industrial hemp, you're moving into a landscape where there's already intensive agriculture happening. Here in the United States, we're pretty much impacted on our land use where we can have open production. And there's existing crops, markets, infrastructure, end product uses that are already well in place. And so when you consider these, and this is from the standpoint of biomass, so whether it's grain, switchgrass, energy cane, biomass sorghum, lipid crops such as canola, industrial rape, even algae or municipal solid waste, there's already established things happening out across the country. And so you have to ask the question, how is industrial hemp going to fit in, to this landscape? Okay. Now let's kind of talk about the realities of how much productivity can you expect out of industrial hemp. Here's a list of, excuse me, of common oilseed crops, and I've included industrial hemp in here. The point of this table is not to argue about the absolute amounts there, but just kind of talk about the relative positioning of these. But you can see industrial hemp does not produce all that much oil from its seed, on what would be estimated on per acre gallons produced. The reason why there's been such expansive establishment of palm oil plantations, particularly like in Indonesia and the South Pacific region, is because you can see the huge oil yield potential of something like palm oil. Jatropha is a shrub that makes an oilseed bean, and you can see how high it is. And even here in North America, castor bean, if that were to be developed, would be fairly. You see the annual crop rapeseed, canola, it has a fairly high yield. So these are the competitors when you talk about, okay, we want to, make, say, use a hydroprocessing to turn the oil into aviation fuel, diesel, gasoline, green gasoline, whatever it may be, that you're seeing that there's other crops that can produce far greater quantities of oil per acre in any given year. So you have to consider hemp within that context. That's not to say that hemp can't be worked on and its genetic, tapping into its genetic potential and achieving that, but it's just something you have to consider. And if you look at cellulosic biomass, it's the same deal. There's some crops such as energy cane, which is very substantial. And when you take a look at energy cane and energy beet, it's not only the cellulose, but those are also high sugar-containing crops. And so depending on your conversion pathway, you really can get a lot more bang from the buck. Again, depending on the process that's used for converting to end products. But again, you see industrial hemp is not as great in its capacity of making biomass as, say, some of these other crops. Okay, now another point that's very important to bring out about industrial hemp, and this is really kind of the whole lore of of industrial hemp is that there's a huge number of products that can be produced from it. We go back to the 18th century. Much of the ropage, sails on ships, and so forth were made from hemp. There's a long history of this. During World War II, there were incentives paid to farmers in the United States to grow hemp so that fibers could be made from it. But what you see here is that basically the two main raw materials that you have would be hemp stalks, which through a number of processes can lead to fiber, other material that can be made into fiberboard as well, and so forth. The hemp seeds and what they can be used for, a broad range of materials, but also thinking about the hemp flowers. And frankly, that's where a lot of the secondary plant products are, the various things such as CBD, which is, again, a lot more research needs to be done, but various pharmaceuticals can come out of it. But again, you can see there's a wide range of materials that can be produced from industrial hemp. Noticing this too, just to give you kind of a rough idea, I made several years ago for our vice president of research at Colorado State, I did some back of the envelope calculations. And depending on where you're growing industrial hemp, and based on a typical, $75 per ton of biomass, industrial hemp, just on a biomass standpoint, can be somewhat competitive with corn, irrigated corn. They have to be irrigated hemp. Again, the value of products that come out of the seeds, can add some value to that. The hemp flowers, though, again, with these pharmaceutical materials, precursors can be very high. And in fact, when you're looking at $600, $700, $800 per acre for agronomic purpose grown hemp, but then let's say that you grew marijuana in an open field, you're comparing $600, $700 per acre to say $15 million per acre, for THC containing marijuana. But again, the pharma end of that is where the higher value products really lie than in the standard materials. And again, going to the previous slide back here, that's what you're having to think about, okay, is that what are you growing the hemp for? And if you're competing with, straw, switchgrass, energy cane, whatever it may, municipal solid waste, willows, poplar trees, for woody biomass, you really have to be thinking about what's the market value going to be on those and how does it compete. Okay, now let's kind of move from talking about the specifics of hemp, but how do we go about funding this type of research to get at these questions? And I don't know how well you folks are familiar with USDA, National Institute of Food and Agriculture, but we're the premier extramural funding granting agency in USDA. We're probably the best in the world. Have about $1.5 billion a year that go out in competitive grants and capacity funds, and we cover just a whole gamut of agriculture-related parts of the value chain for agriculture, food products, and natural resources, and so forth. And what I want to show you then is within, peel back the curtain a little bit and talk about our grant programs and how industrial hemp can fit into these. And I'm using it as a framework the programs that were in the President's 2017 budget. We still don't have a budget passed by Congress. We don't quite know what to anticipate going into this next year. But I want to talk about the programs that are available so that you can see how they would work. Now, excuse me. What's important to think about, again, this is my opinion, particularly coming out of the dedicated biomass for aviation biofuels. But, we got to think about the whole value chain and what's involved and what are the challenges that we would face in trying to establish a new crop such as industrial hemp. So, and, maintaining the genetic and physical purity of the seed, that the seeds represent the genetic materials that you want. They're not contaminated. Think about production, the harvest, the processing, and particularly with a crop such as industrial hemp, depending on what way you want to go for end products. But thinking of the raw materials, processed oils, meals, fiber that would be coming out of that crop after harvest. And then thinking of the end products, as we've mentioned, the pharma, foods and feeds, fuels, even manufactured products. I don't know if you're aware, but BMW uses a fair amount of hemp in a number of its component parts of cars, body liners, dashboards, so forth. It's just an awful lot of manufacturing goes into it. There's some very necessary, but there's some very advantageous physical properties to industrial hemp that lend itself to these type of processes. But again, the point to make is you really got to be thinking, what's your end product market that you're looking at, and how do you think about defining the quality, the use, and the need for the value-added research to really define where do you want to be with this. It has to be market-driven varieties that have to be created. It's just not this like a wheat crop or a forage crop, an alfalfa crop. Let's just go plant it and assume somebody's going to purchase it. There really has to be an end use in mind as to why you're growing that. And based on this, then would come in the need for specific variety development, the breeding of industrial hemp for adaptation to different environments in the country, different rotation systems, how it would fit in. It's thinking about the pest management, the diseases, the insects that would strike this crop. The resource management, how it fits in the. And I know there's a lot of interest in Pennsylvania as it being a conservation crop to help reduce erosion and runoff, but also things such as nutrient deficiencies and other abnormalities, abiotic stresses that maybe the crop could face. There's research needs to be done on that. And not to even speak of the engineering aspects of this, the processing technologies. When a crop such as this that obviously does have a lot of versatility potential for how it could be used, it's been somewhat of a time warp, for really looking at how do you extract materials out of it and develop the markets that can utilize those. There's also just the whole issue of how do you manage risks, which could be such things as crop insurance, but also to ensure that the supply chain, the value chain is protected so that there's a steady stream of material, high quality materials that are able to be delivered on time, particularly with a crop that has a lot of manufacturing potential of how it's utilized. So again, it's taking a look at this as a system, look at the whole utilization value chain, and how do you create and protect a sustainable value chain that that's going to be resilient and carry on into the future. So let's talk a little bit about the NIFA programs that are available. AFRI, the Agriculture and Food Research Initiative, funds about $350 million worth of research a year. Because of these legalities that have been worked out with industrial hemp between USDA, DEA, and particularly DEA, is that now any of our research programs at NIFA can be applied to industrial hemp. So in other words, industrial hemp is treated as any other crop. And so therefore, any of our programs can be accessed. It's just that you have to come up with competitive proposals that are able to beat out everybody else, to get the funding. But there's two general types of grant programs, our foundation programs and our challenge areas. There are no special grants for industrial hemp. That's another way of putting what I just said a minute ago. But the foundational programs are available in plant health, production, plant products. That would include plant breeding, looking at nutritive components that can be extracted out of hemp, other physical materials, whatever it could be. Our bioenergy, natural resource environment grants are available, ag systems and technologies, and then I'll talk a little bit more about this, the Critical Ag Research and Extension Program, which really helps translate the fundamental research into applications, getting it used by producers, people in the value chain. Those grants are up to about $500,000 a piece. And then there's challenge areas also, which can be $1 million more. Those have gone as high as $40 million in the past in bioenergy. But again, you can see there's programs underneath that where those fit. There's some other programs under discretionary funding. Penn State is a land-grant institution. Again, I assume your guys' department's over in engineering, so you may not be as familiar with this, but there is base funding that does come into Penn State to support research and extension, not 240, 40, and 300 million just for Penn State, but a portion of that does go to Penn State. And so those funds can be used locally by the university, either into competitive grants or to support faculty salaries, but just be aware that those are there. And then there's other research such as the SARE program, Sustainable Agriculture Research and Education Program, that this could apply into, and even pest management through the IR4 program, especially for novel crop such as this, which has very, very limited acres at this point. Okay, and then finally, there's a little bit of other mandatory funding, endowment funding that's available, the Biomass Research and Development Initiative. This is down quite a bit from several years past, where it was up to $12 million a year. Again, I think it's a bioenergy crop as such. I think it's a little different with hemp. I think there's other areas, I'll talk about that in a second, that are probably more rich targets to go after. But you even have grants within USDA that helps move the technology into the marketplace, such as the USDIR, as well as Natural Resources Conservation Service conservation innovation grants that can help use or determine the practices that would be of value to the environment that hemp bestows and get money there, as well as USDA Rural Development Programs can help startups and businesses. Okay, so finally, last series of slides on this is going back to that value chain. You know, how do you look at all these USDA programs and where they fit? Again, the AFRI, plant health and production and plant products would fit into plant breeding, production, getting at specific materials that could be of value to push along that have higher value. The minor crop pest management program, so that we could, have weed-free, bug-free, disease-free crop that's out there. You can look at supporting the natural environment, look at the environmental footprint. The industrial hemp could, help reduce a negative footprint. The systems technology programs, particularly as they relate to harvest and processing later. Again, the conservation grants, the extension programs. Looking at biomass research and development, bioenergy, but even looking at, the getting science-based information about any health benefits, nutritive or medicinal values of that would come out of industrial hemp, or as livestock feeds. There's programs that could fit into. And then again, the commercialization, as we talked about a minute ago. All of these are, again, the purpose of these is that you can pick and choose from these different programs, but it's critical to have a plan for where the research should go. What are the needs that are out there? And that's one of the main points, kind of the take-home message I'll say here at the end, is that in talking with the industry groups that have come through DC, we talk about industrial hemp in these terms that I'm presenting to you right now. And we really encourage them. There needs to be and let's say Pennsylvania, there needs to be a value chain research strategy for Pennsylvania. How does this fit in? And what are all the pieces that need to connect together? And it's from that type of framework that we probably have the best chance of helping accelerate and move along industrial hemp as a crop. So anyway, that's what I have to present to you folks. I'll be glad to answer any questions you have. So let's take it, throw it back to you guys.
Okay, thank you very much, Jeff. We'll just open it up to questions to, I guess, the students first and then other visitors after that.
Be sure to introduce yourself by name.
Hi, I'm Jessica.
Hi, Jessica.
Hi, I'm a grad student here. I do have one question. I know hemp in this country. I've heard a lot of talk about it trying to replace specifically cotton. Looking at specifically cotton uses a lot of water, puts a lot of stress on that. And I was just curious how, hemp could specifically help with the water, and would that be a fair replacement for cotton in the future?
I haven't seen any, Jessica, I haven't seen any, it's a good question. I haven't seen any water balance studies off of industrial hemp. But what would be necessary would be to see what its actual water consumption use would be. Going into cotton, you're primarily looking at Pima types now. There's still Acala types down in the Southwest, out in California. There'd have to be a real close examination of that. You raise an important point, and there was a similar kind of a folklore perspective of another alternative crop called camelina. Perhaps you've heard about it, oilseed crop. And it was purported that you could grow it on wasteland, marginal lands, doesn't need water, doesn't need fertilizer, it just basically grows robustly. And that was totally false. And a concern that I have on industrial hemp right now is that a lot of work needs to be done. There's a lot of information that is available in Europe, China, Canada, but that's an area you just have to be real careful about when there's claims that, it saves water, you can produce so much more. That you got to be careful of that. And then it gets down to the fibers that are produced by industrial hemp and what are they going to be used for. But I do know, there's very high-end clothing manufacturers that are using industrial hemp. Most of that is coming from being produced in China. And I think, is it Prada? I think it's a high-end clothier. They're using industrial hemp, so it does have, that high value. And just to throw at you another point, and this is what takes more research, supposedly the fiber has some very good natural antimicrobial activity in it. And supposedly the Chinese military use a percentage of industrial hemp in all of its underwear for its military, because again, it cuts down on bacterial infections on skin and so forth. So again, it's one of those things. I'm not cynical. I'm very positive. I think we need to look at those things, but you have to be very careful, and we need science to prove out all the claims. So how does that help you, Jessica?
Did that answer your question?
Yeah, no, that answered it. Thank you.
Hi, Jeff. My name is Mark. I'm another grad student here with Jessica. Thanks again. I guess not that Jessica stole my question, but it was more around what do you see with the yield levels and the strain on resources? What do you see as the next big innovation that has to happen to really push hemp forward?
Again, I think you have, and what was your name again? First
Mark.
Okay, Mark. Again, I think there has to be some very careful consideration of the market and the end product that's going to be produced. I just from my experience and looking at history, there better be a very clearly defined market and product that is going to, there needs to be sophistication in the contracting, so that that somebody doesn't grow it and then have it in a barn for 3 or 4 years hoping somebody will buy it. And so again, there just needs to be good studies comparing, in let's say in Pennsylvania, what are the production capabilities that you'd expect, how much biomass can be produced, how much oil can be produced, the meals, going for probably the higher value end products, so if it goes into textiles or manufactured products and they have a proven benefit over another biomass crop, those are the points that you just have to know ahead of time. There's a certain wave of goodwill and enthusiasm that people have towards industrial hemp, and so I think there could be a premium that could be obtained because of the novelty of industrial hemp. But when markets get mature, people get pretty pretty much down to the bottom line, and it either it's going to prove itself or it's not going to prove itself, and that'll be a matter of whether it takes off in the market.
Thank you.
Well, thank you very much for your presentation. My name is Veronica. I'm also another grad student working here with Professor John Richard. And I had a question. Why do you think a farmer would prefer to possibly plant industrial hemp rather than, for example, miscanthus or switchgrass, where we know there is much biomass production and there are many existing services? So what would be, like, why would the farmer choose this plant then?
Veronica, could you get closer to the microphone and just say your question over again?
Sorry.
She's moving this way.
I'm coming closer.
That sounds much better.
Okay. So my question was, why do you think a farmer would choose to plant industrial hemp rather than something like miscanthus or switchgrass, which are more, well, established is maybe a bad word, but where we know the ecosystem services, the large production of biomass? Why do you think this would be as a good possible plant?
You know, if I were a farmer, I wouldn't go out and put in a large planting of industrial hemp unless I had a contract for my market of what it's going to go to. The crops that you mentioned, miscanthus, switchgrass, those are perennials. So once established, they're established. They have to be applied. They have to be planted each year from seed because it's an annual and it's not tolerant of cold temperatures. And so, I'm a farm kid. If I were to look at this right now, I'd want to have a very clear market in mind and have a contract with somebody to grow it. That's not to say I wouldn't grow some of it on my farm just to see how it grows and start getting some experience. But that's going to come out of the capital of my overall farm supporting that. That's why it's critical for universities like Penn State to get fully engaged in this and to talk, square turkey with folks about it. Because very quickly people can become disheartened if they put a lot of money into it and then it just doesn't pan out for them. So that's where I come from on that, Veronica.
Thank you.
So I had a similar question, and I don't know what the existing literature holds on the research, but has there been much side-by-side comparison? I mean, you mentioned that as far as the cellulosic biomass, that hemp is somewhat similar. I mean, it's in the same range as switchgrass. Has there been any side-by-side comparisons of yields and harvest rates and total energy output that you're aware of?
In the United States, I think very little. Because up until the past couple of years, you couldn't grow it without being violated, without DE agents coming in and Black Hawk helicopters coming down, taking over your farm. And
okay.
So that's a joke. But so, that work hasn't been done. Again, I think this gets into the point where it's critical to have a research strategy, a real plan. And I think that this is what we tell the university folks or the industry folks when they come through is you should engage your universities like Penn State and you folks really help them come up with a plan on how to move it forward. Look at the slide that I put back up here, those end products, those are pretty well defined and where they're going. So the issue is, can you produce the raw materials that go into those end products cheaper than the Canadians, cheaper than the Chinese? Are there other values that you can your researchers can add to it? Can you come up with a good genetic program? Can you get this thing mapped out, get linkage maps to value-added traits that are identified and get that work done? There has to be production research and so forth, but really you need to have this whole this whole ecosystem of aspects of that value chain addressed And there needs to be good heads put together to make this work if you want to have it succeed.
Okay, we have our two visitors here. If they want to ask a question, they're welcome to do that.
Jeff, this is Matt. Just a little broader topic. What do you think the future is for renewable research funding and maybe even agriculture research funding in the future? I can imagine you and some of your MPLs are probably, and maybe even some of the folks above you are wondering what the future holds with the change of administration. Can you talk at all about how maybe the agency is positioning itself for the change, or what some of the thinking might be?
Well, I think good question, Matt. And, this is no different than any other change of administration.
Well, I think this one's a little different.
We'll go along with it. I would say there's been a good move within the USDA research agencies to becoming more and more relevant to practical problems of the American people, and accountability structures around that. Matt, for those in the room, Matt and I both were with Agricultural Research Service, which is the intramural research agency of USDA for decades. And so, we're well positioned from the standpoint of the AFRI program. We've seen the NIFA budget go from $1.2 to $1.5 billion to where it's at now. There's strong support in Congress for agricultural research, both sides of the aisle. There's been a good return in dollar. 1 in 10, 1 in 12. $10 or $12 in every dollar invested in agricultural research. And, and even during the recession, the only positive during that 4 or 5 year period was ag exports. And so we do very, very well in the ag market. And so there's more and more need for bio-based products. So Matt, I think, that is a good pull on the end. We've done well. We just have to see what the priorities of the administration are. But in some ways, we're kind of low on the radar, because we're not huge like HHS and others. And so we'll just see what happens down the line.
Any rumors on the Ag Secretary?
Look at Politico. They got a good listing. You can look at it. There's about 6 candidates.
Thanks, Jeff.
Sure thing, Matt.
Jeff, can you hear me okay?
Yes.
Okay. My name is Ron Hoover. I work here in we used to be agronomy, back whenever I came here to do a master's degree. Department of Plant Science now. So I'm an agronomist in training from a farm background also. In fact, spent yesterday traipsing around our home farm chasing after some deer, and had the and as I do that, it's a quiet time and an opportunity to kind of reflect on things that have happened there, as well as things that I get involved in here in my job at Penn State. And as I think about like what my brothers are doing now with our farm and how I interact with farmers here across the Commonwealth, there's always this, is there something better? It's always the underlying question. Is there something better that I could be growing on this part of the farm or in those fields than what I did last year? And quite honestly, I'm still at a loss to find the niche, if you will, or the attraction of industrial hemp here in Pennsylvania. I guess the big hope for it was that it was going to, buttress, if not surpass, or had potential to surpass switchgrass and miscanthus in terms of cellulosic. But then you come back to there's still that question of how when is the day going to come to where we've gotten our ability to convert cellulose into transportation fuel, which I think is what everybody's hoping for. And partway through our third 5-year cycle, where it's in another 5 years from now, sort of thing. To a grower, if you were to sit down with a group of growers, I guess that's where I'm coming from here. If you sat down with a group of growers and you were asked to defend or predict where this crop would have a place in northeastern agriculture. I know you kind of painted a broad brush here during your seminar, but are you able to be more specific where you would think this would have a fit? Or are we truly just still looking to identify where it has a fit?
Well, it's a good question. Your first name again?
Ron.
Okay, Ron. My starting place would be what is the highest value product I could produce from hemp?
Right.
That would be the first question. If I was a producer, I wouldn't be looking at generic biomass. The advantage, just from the standpoint of, if you're just making cellulose, I don't know if it's the best crop. You'd have to have those heads-up trials, how does it compare to miscanthus or switchgrass or poplars, up in your region.
Right.
But the thing that industrial hemp has over, say, switchgrass is that there's high quality fiber that can be produced from it from a biomass standpoint. And so there's a first, right off the bat, there's a heads up positive for it. It's able to produce not only an oil, which you see you'd actually be better off growing, canola, rapeseed, rather than oil seed. But then you have the whole feed market, that whether that actually has nutritive superiority over, other grains and so forth, that needs to be figured out. And then on top of that, it has this whole pharmaceutical, the pharma component of it, which could be very, very high value, very lucrative. And so there's some real advantages to hemp over wheat straw, switchgrass, so I think that's a real. And so I guess, going back on the slides, I think what would be a really interesting thing to look at is to get a consortium, a value chain consortium together in Pennsylvania. And then you look at such things as the Rural Development Program. Should there be a cooperative where you produce the raw materials, that have a given market endpoint that's going to go into, and you have kind of create a closed loop system where all participants in that value chain, that's here, that all the participants would be able to benefit out, not just say the end product people get the highest value. Ron, those are the things I think just have to be looked at, but I think you have to go into it with, with, like I say, with your eyes wide open, and be willing to, to throw out any mythology that's out there, where people make claims that are not science-based, not market-based. But that's how I would approach it. Does that help you?
It does, and I guess you confirmed my suspicion that there's still a lot that needs to be learned about the crop and what its potential is, and how we could make use of it. I guess what I was maybe expecting was a little bit more from you. I was expecting maybe a little bit more insight to what some of those potentials are, and I think you have shared some of those. But again, I think that there's still lots of room for better understanding what those opportunities are and further researching those.
Well, let's just get real specific. You look at this past election, and there was a roaring mouse out in the rural lands. The Rust Belt. You guys, Pennsylvania is a good example of that.
Yeah.
What are the hardcore people roll their sleeves up opportunities? And let's talk about manufactured products, like on that slide. Not making raw steel, but what value-added products, are the automobile industry people, Chrysler corporate, they're interested in these materials. And so what can be done in Pennsylvania to create jobs, create manufacturing, looking at value-added products and it's hemp raw material going into it, that there could be those type of possibilities. Can we make, can we restructure light manufacturing, some of that, in the United States? And could that happen in Pennsylvania? That's something to look at. Another one would be the whole foods, feed, and pharma area. And Penn State has excellent molecular genetics. What's going on with what could be created a consortium to identify these materials, work with a pharmacy school, work with, say, an off-campus incubator that could start bringing products to market, potential products to market. So you hit on that higher value end part of the supply chain. Again, hemp has some very unique properties that, say, wheat and switchgrass don't have, and even go into a crop such as flax, which again is a peer of hemp from way back centuries ago. But flax does not have the pharma components in it. I don't know about its fiber. It's a fiber crop too, as well as an oil crop. But I think hemp's got a real foot up on something like flax. So I think those are just things to look at.
That's
Okay.
great. Thank you.
Thanks, Jeff. This is David Jones again. Really appreciate the time and great presentation that you've given us, and lots to chew on and to consider for the future. So thanks very much.
Oh, you're very welcome, David. I'm glad to participate.
Uh-huh.